Hi everyone. So in this video we're going to be discussing how to find intervals of increasing, decreasing, and how to apply the first derivative test. We're going to be working with two examples. The first example is just a basic polynomial expression, and then the next example is working with a rational function. So we're going to go ahead and get started. Anytime they ever ask you to find the intervals of increasing, decreasing, or even ask you to apply the first derivative test, you have to actually use the first derivative. So you always want to start by finding the first derivative. In this case, the first derivative of this expression is going to be 3x squared minus 12x, and then remember 26 is going to be 0. Now after you find your derivative, you want to find something called critical numbers. Critical numbers are found by setting your derivative equal to 0. So once you find your first derivative, set equal to 0 and try to factor it out. Solve for x. So in this case, I'll notice that I can take out a 3 and an x, and I'm going to be left with x minus 4. Now after you set them, you factor out whatever they have in common, set them both equal to 0. 3x equals to 0, x minus 4 equals to 0. And solve for x. I get that x equals 0, x equals to 4. The values you just found are your critical numbers. These are also called resting points. Now, what you do with these critical numbers or resting points is you want to graph them on a number line. And what I tend to do is I always put boundaries, because I want to test intervals left of 0, so I'm going to pick any number, -1, any number between 0 and 4, 1, any number greater than 4, 5. Now it doesn't matter the values that you pick to test. Now to actually figure out what's happening between these intervals, we have to plug these numbers into some equation. The equation that we're going to always plug them into is the first derivative, since we're using the first derivative to determine increasing, decreasing, or applying the first derivative test. And the derivative I always want to plug it into is the one that's factored. So let's say we plug in -1. 3 times -1 times -1 minus 4, and that's going to give you -3 times -5, which gives you positive 15. So because it's positive, that means that between the points -infinity to 0, you are going to be increasing. Now a shortcut to this is don't actually find what number when you plug in -1 it gives you. Plug -1 in your head. 3 times -1 is a negative. -1 minus 4 is a negative. A negative times a negative will give me a positive, because when you're finding increasing, decreasing, a positive is always going to be known for increasing and a negative is always going to be known for decreasing. So let's plug in 1. 3 times 1, positive. 1 minus 4, negative. Positive times a negative, negative, meaning the interval between 0 to 4 is going to be decreasing because it's negative. Then do the same thing for 5. Positive, 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 meaning it's increasing. Now what you just found was the intervals of increasing, decreasing. So because it's rising from -infinity to 0, that means it's increasing from -infinity to 0, 4 to infinity. And it's decreasing from 0 to 4. Now the only thing that I can tell you to be careful on is when you actually write these out in an interval notation, make sure you put your critical numbers. Because sometimes when we're actually working on a problem and in the heat of the moment, we'll plug in the numbers that we're testing into our intervals of increasing or decreasing. Okay? And that's how you find increasing or decreasing intervals. Now the next step is, well, how can we actually find resting points? No, not resting points, sorry. First derivative test. How can we actually apply the first derivative test? What the first derivative test tells us is any interval that's increasing, you see how I'm connecting them, and then decreasing will create a maximum value at this critical number or resting point. So that means that because it's increasing and decreasing, there is a max at 0, something. Well, how am I going to figure out where it actually is? What you need to do, since you're finding out a real point where this max is going to be, you need to plug in your 0 into your real equation, which is your original, f of 0. So when you plug in f of 0, you're going to get 0 cubed minus 6 times 0 squared plus 26, which will just give you 26. So that means there's a maximum value at 0, 26. Well, what about at 4? Is there anything happening at 4? Well, it's decreasing, and then it's increasing. Well, that means that there's a min. So there's a min at 4, something. And where are we going to plug this 4 into? Your original expression. So when you plug in 4, you're going to end up getting -6. So that means that there's a maximum at 0, 26 because it's increasing and decreasing, and a min at 4, -6 because it's decreasing then increasing. That's how you apply the first derivative test. The first derivative test wants you to find any extremas, which are also known as max or mins. So now we're going to work on our second example. F of x equals to 3 over x minus 4. Well, in this example, anytime they ask you same thing, increasing, decreasing, or applying the first derivative, you have to find your derivative. So because it's a rational expression, you might want to think, oh, let's do quotient rule. But you actually don't have to. Because anytime the numerator is just a constant, you're going to put this in parentheses. Well, it's going to be raised to the first power, and then bring it up. So it's 3x minus 4 to negative first power. Now your next step is, we'll find your derivative. Because this is just a constant, that means that this is just a regular chain rule. So my derivative is going to be -3 x minus 4, subtract by 1, -2, chain rule it, which is just 1, multiply first and last, you get -3 x minus 4 to negative second power, but I don't want to keep it like that because I want to put it in simple terms. You're going to get -3 over x minus 4 squared, and that's your first derivative. Now the unique thing about rational expressions is that to find your critical numbers, you have to set the top equal to 0, and you also have to set the bottom equal to 0. So if you set the top equal to 0, you're going to get -3 equals to 0, which doesn't really make sense because how can I solve for x? There is no x. And also -3 is not equal to 0. So when you can't solve for x, there is no critical numbers there, or resting points. What about x minus 4? Just set the parentheses equal to 0. Solve for it, you get x is equal to 4. That means that x equals to 4, you have a critical number or a resting point. So what you're going to do is you're going to put this number on a number line, separate your boundaries, pick a number left of it, pick a number greater than it, then plug them into your equation. Well, if you plug 0 into your bottom, 0 minus 4 is -4, -4 squared is positive 16, -3 over positive 16 will give you a negative, which means it's decreasing. But there's a shortcut also. Anytime you see that your entire bottom is being raised to an even power, that means it's going to turn out to be positive. So you should know that this is always going to be a positive no matter what number you plug into it. So let's check 5. 5 minus 4, positive. Remember, anything raised to a second is positive. So negative over positive, negative, so it's decreasing. So when you're finding your intervals of increasing, decreasing, it's only decreasing from -infinity to 4, 4 to infinity. Well, what happened to, why couldn't I put -infinity to positive infinity? The reason why you can't put this answer is because nothing is happening at 4. 4 is a resting point, a critical number. That means it's not increasing or decreasing. So you have to make sure, even though it's increasing throughout its entire domain, it's not increasing, decreasing at 4. Okay? So that's why you put -infinity to 4, 4 to infinity. Well, let's apply the first derivative test. Can we actually apply this? Well, remember, first derivative test only works when it's increasing to decreasing or decreasing to increasing. So if we look at -infinity to 4, it's decreasing, and from 4 to infinity, it's decreasing. So there's no extremas, no max or mins. Now, one more thing I want you to kind of memorize is, in the case where your critical number, which is 4, is also your vertical asymptote, and remember, you find vertical asymptote by setting the bottom equal to 0. When you plug in x minus 4 equal to 0, you get that there's a VA at x equals 4. Your critical numbers, if they are your VAs, they can never be a max or a min. And that's something you just kind of want to just take down, so when you're actually applying the first derivative test, you kind of notice it and apply it. Alright, so a recap of this video. Anytime you want to find increasing, decreasing first derivative, you actually want to find your first derivative and set equal to 0. Now when you set it equal to 0, the numbers that you're going to find are called your critical numbers or your resting point. Alright, hope this video helped. Thanks for watching.